is okay. Okay. So yeah, yes, guys, I was stuck somewhere, so I couldn't join on time. I'm really sorry about that. Yeah, I had some work going on, so I was not able to join on time. Okay. So let us carry on with our concept. Yes, what we have done in our last class, we have done design, right? We have done a design, right? The design wherein we had has a and a is a relationship. Yes, has an is a relationship we had. Okay. So yeah, so we shall execute that code again. Okay, and let us go forward with our next concept. Okay. So let it open. We'll execute the code and we'll go back to our portions. So we have okay, we have gone for SPI driver class. So SBI driver class we have executed and yeah. So people has left the class earlier in the last class, but now okay, let me explain you guys regarding the output. Listen carefully, everyone. So we have six options. We have six options: create account, withdraw amount, deposit amount, check balance, change password, and exit. Okay, so these many options are there. Now what we have to do, other than exit, you can go for any option, but as a good programmer you have to not choose create account first. You have to not choose for creating account, you have to choose for withdraw amount. All other options you have to check. Okay, you have to check all other options before going for creating account, because when you're checking all other options you will know if they're working fine or not. Okay, so we'll go for the second one, that is withdraw amount. So password I will give you 1234 and amount to withdraw I'll give you 500. Okay, and and now what are we getting? Account is not created. Account is not created. Why? Because we have not created any account, right? So that is why it is showing account is not created. So if you go for the deposit amount method, the password will give us 1234 and the amount to deposit will take 500. And what is the account is not created? Why? Because we have not created account yet, so that is why we are getting account is not created. Then then we shall go for checking a balance. So password will give you as 1234 and what is the output we are getting? Account is not created. Account is not created. Okay, and if you go for change password, okay, if you go for change password also, you have to still get the same output. You go for 1234 old password and new password 4321, if you take, and you'll be getting account is not created. Since we have not created account, so you are getting account is not created. Now what we'll do is let us create account first. Account number, we'll just enter some random numbers into numbers, I mean long numbers. And available balance, listen carefully, remember the available balance. Available balance we can take as a 5000 and a password we can take as a 1234, and you can enter name like Kumar. Okay, next contact number, some numbers, some random numbers you can add. Okay, next Aadhaar number. Okay, this my number we can give. Now what are we getting? Account is successfully created. Account is successfully created. Now if you're going for checking other options now, okay, like withdraw amount. So password we have entered is 1234. Okay, 1234 is the password we have entered, and amount which you have to withdraw. Amount which you have to withdraw. Suppose you have 5000 amount, so out of that 500 I'll withdraw. So what is shown here? 500 has been debited because we have withdrawn, no, so it's showing 500 has been debited, and the available balance is 4500. Available balance is 4500. Okay, and next we'll go for depositing the amount. Depositing amount is option 3, password 1234 And the amount to deposit is if you take 100 rupees. Okay, so what is the amount credited? 100 rupees has been credited and the available balance is 4600. So how much was here? 4500. 100 extra added, it will become 4600. Next, if you go for checking the balance, password 1234, and what are we getting? Available balance is 4600. 4600. Okay. And next, option 5. Okay, that is change password. I'll give you old password 1234 and a new password 4321. Okay, so what are we getting? Password has been changed. Password has been changed. So now if I go and check the balance again, if I enter the password 1234, I will be getting a error that incorrect password. I'll be getting a error that is incorrect password. Why? Because I have not entered the updated password. Earlier old password was 1234, now updated was 4321. Updated was 4321. And now currently we have 4321 as a password. Now we are giving old password, it will not take. So if you want to, suppose if you want to go for checking a balance, you have to give updated password, that is 4321. You have to get a, you have to give a updated password, that is 432 and 1, and now you will be getting the balance. Okay, and if you give any wrong input, like 7, what are you getting? Invalid choice. Okay, we are getting in red because you have not chosen the given options. And if you are going for exit, you can go and it will take you out of the program. It will tell thank you and it will take you out of the program. Okay, so that now our code is completed. Okay, this is how we will deal with our code. Okay, so this is how we have done SBI software, and this is just for the code. SBI class, can you explain? Okay, sure. See, SBI, okay, this is a class. SBI is a class which inherits bank, which inherits bank, and it has attributes branch name and bank IFSC. And here we are achieving has a relationship from the account A and class SBI. So here we are doing later lazy instantiation because we have aggregation. The level of dependency is aggregation. So we are doing later lazy instantiation. Then to indicate that we are doing later lazy instantiation, we have mentioned the account A inside a create account method. And we are checking if account is null. If this dot A is equal to null. Okay, if this dot A is equal to null. Okay, if it is equal to null, then that means there is no object. If this is equal to null, means there is no object and we are creating an object here. If this dot A is equal to null, means here also in this dot A also null we will have. Null equal to null, it is true. And this dot A means we are creating an object, and then we'll be getting account is successfully created. We'll be getting account is successfully created because when there is no account object, we have created one, and after creating we are telling account is created successfully. Then after this, so in the create account, in case there is no object, account object, we are creating one. But what if there is already an account object? What if there is already an account object? If already there is an account object, we will be telling account is present already. Account is present already. That is for create account. Next, we shall go for check balance method. We shall go for check balance method. In check balance method, we'll have a password, okay, as an input, because for checking a balance, surely you need a password, right? You need a password. And you are checking here, if this dot A is equal to null, that means if there is no account object, you have to tell account is not created. If there is no account object, you have to tell account is not created. If there is an account object, this condition will become false and control comes to else. And after account is there, we are giving password and checking if password is matching or not. After account is there, we are checking if password is matching or not. Okay, we're checking if password is matching or not. Okay, if password is matching, okay, we will be showing the available balance, or else we will tell incorrect password. So deposit method, you already know. If account is not there, tell account is not there. If account is there, check password and call deposit method from the class account, and it will be validating everything. If there is password wrong, I mean incorrect password, you'll be getting a incorrect password in your output. So in withdraw method, both password and amount has been taken, same thing. For withdrawing, here verify password you have to do, after you have to call withdraw amount method. If password is wrong, we'll go for incorrect password. Change password, if there is no account object, you have to tell account is not created. But if there is account object, you have to tell, I mean you have to match with current password and the old password. Okay, what is the current password? Current password is in the get password, and old password is a password, same password which you have given. There is no different password. This get password and the old password are same. Okay, get in the get password, current password will be stored, and for us it is a old password because we will be changing now. Okay, that will be telling as a old password. Okay, if it is matching, we will be going for set password method, and with the help of a new password we'll be changing or we'll be reinitializing the private variable password. And after that we'll be telling password has been changed. If there is no password matching, if password is not matching, then you'll be telling incorrect password, incorrect password. Okay, this is about your SPI design. Everybody understood? Okay guys, so so in last class we have done a design. Okay, after the design we shall go further with okay we'll go further with some more designs and different type of inheritance also. So okay, we have done only design now. Okay, yeah. So anywhere any doubts you have, I have not sent the program for you because a few people were not there when I was explaining the program, so that is why I have not sent you the program. So today I'll be sending you the program. Okay, so anywhere any doubts you have, you can let me know. In case if you have, in case any doubts if you have, you can let me know. Okay, I think no doubts, we shall proceed further. Okay, let us carry on now. Okay, so let us go for the paint and let us start today's portions. Okay, so guys, here if you take one student object, okay, if you take one object, maybe student, take an object that is student, okay, is an object. Student will have minimum two attributes, that is student name, that is S name, and student ID, SID. Okay, and student is an object and we can create a class of student. We can create a class of student. Now we shall create a class student, and here within the brackets, okay, within the brackets we can go for here we can have an attribute string yes name of the student, string yes name of the student, and if we create an object for the yes name, that is in case inside main method if you create public static void main string array arguments inside main method, if you are trying to create an object for student, how you can create student yes is equal to new student of no argument constructor. Student s is equal to new student of no argument constructor. So what is this? We have created an instance for class student. We have created an instance for class student. Okay, and after that here, okay, let me take this object. Now what happens is because of this variable s, okay, because of this variable s, there will be one memory created in the heap area. There will be one memory created in the heap area. Maybe address is 0x1. Now Now there is a attribute s name. We can also add sid, that is int sid. Okay, so what happens now? New keyword will store, I mean s name will be having null because we are not initialized, and sid will be 0. Now what happens is, now variable s is pointing towards this object, right? Variable s is pointing towards this object. Okay, fine. Now what if I create one more object like this, like student s1 is equal to yes. Okay guys, now tell me what is the address present in s1. What is as the address present in s1? Can you tell me what is the address present in s1? Yes, it is 0x1 only. But why? Yes, correct. Because S is having address 0x1, and that S we are reinitializing. Okay, we are initializing to S1. That S only we are reinitializing to S1. We are reinitializing to S1. Okay. Now, since we are reinitializing to S1, okay, now S1 is also pointing towards this same object. S1 is also pointing towards this same object. Okay, and and after that, suppose if you create one more object like this, you can go for student s2 is equal to yes. S2 is equal to yes means what? Obviously whatever data is in yes, so maybe 0x1 is there in yes, and it will also store in s2. And s2 also will be pointing towards, s2 also will be pointing towards 0x1. s2 also s2 also will be pointing towards a 0x1. Okay, so like this your multiple reference variable will be pointing towards one object. Okay, we can refer an object with the multiple references. Now we have only one student object. We have only one student object, right? Okay, only one student object we have. Now that one student object can be referred with multiple reference variable. Say s is also pointing towards 0x1, s1 is also pointing towards 0x1, s2 is also pointing towards 0x1, right? Only one object we have, but multiple reference variable we have taken. Explain again, please. Okay. Okay, so if you take a object, so if you take a class about class student, student will have s name. Suppose only s name we will take string s name of the student. And suppose in the main method, assume we have created an object, that is student s is equal to new student of no argument constructor. Now new keyword will create one memory, maybe 0x1 is the address, and student constructor will load, and s name will get loaded with the default value null within. Then student will return the address to new will store the address inside variable s1. So currently inside variable s we have the address 0x1. Inside the variable s currently we have the address 0x1. Okay, we have the address 0x1. Okay, then after this, next, now s1 s is pointing towards 0x1. Now if you go for creating one more student s1 is equal to yes. So what we are doing here, we are passing the variable s address to s1. We are passing variable s address to s1. How we are able to pass it so easily? Because the return type of student and this student is also same. The return type of this yes is also student. Return type of s1, and that is data type of s1 is also same. Since the data type of the S and the S1 is same, you can easily store the address of one reference inside another reference. You can easily store address of one reference inside another reference. Okay. Now here So student s1 is equal to s means this variable s will be giving an address, and variable s currently is storing inside s1 variable. Okay, the address of s is storing inside s1. And here why it is getting stored in s1, because the student type and the student type both are same. S is of also student type, s1 is also of student type only. Okay, so that is why they are able to reinitialize or initialize the address with to the new variable. Okay, suppose if we take one more variable, one more student here, student s2 is equal to same s. Now it means the s has a 0x1 and actually it has been stored in s2. Why? Because the type, the data type is same. Here also student, here also student, here also student. So since we have same data type, since we have same data type here, since we have same data type here, we will be pointing s to the 0x1, s1 to the 0x1, and s2 also to the 0x1. So here, so here it's not like swapping, it's initializing. It's initializing. Okay, which means to one type of data type. Okay, it's like to one type of data type you can initialize a number of times. Okay, suppose if you take a int. Okay, if you take int a is equal to 5. Now int b is equal to a, I can give. Yes, guys, tell me, can I give int b is equal to a? Int b is equal to a, can I give? Now what is the value of b? B value is how much? 5. Okay, now I'll take int c is equal to a, I can give. Now what is the value of c? Value of c is 5 only. The same way, here it is primitive, but here it is non-primitive. That's it. Here see, the data type is same, student, student, student. One address we are storing in S1 and we are storing in S2. That's it. Nothing we are doing. One address we are taking, we are storing in S1 and we are storing in S2. That's it. And these three references, S and S1 along with the S2, they are all pointing towards one address, that is 0x1. They are pointing towards one address, that is 0x1, which means one object can be referred with multiple reference variable. One object, okay, one object can be referred with multiple reference variable. With multiple reference variable, they can be referred. Okay, and we can copy the reference of one object into the multiple reference variables. You can take address of one object, you can take address of one object, and you can copy that to any number of reference variable. Any number of reference variable you can copy, but all those reference variables should be of student type only. All those reference, I mean all those reference variable type, this also should be of student, this also should be of student type, this also should be of student type. So whatever the reference variable you're taking, everything should be of student type. If it is a student type, then only we can store the address of one object inside another. But if it is of different type, suppose if you're taking student s is equal to new student, and assume student has a address 0x1. Okay, now if you're taking teacher t is equal to s, storing 0x1 inside t. No, this is not possible. This is not possible. But why? Why is this not possible? Okay, why is this not possible? This is not possible because student is of different type and teacher is of different type. Student is of different type and teacher is of different type. Suppose if you create one more student object, student s1 is equal to s. Now it is possible. Yes, address that is 0x1 will be stored in s1. Yes, you can store. So s and s1 will be pointing towards the address 0x1 only. Why? Because student type, its s variable is of student type and s1 variable is also of student type. Since both of them are of student type only, that is why we are going for, I mean, we'll be able to store the reference. So one object you can refer with multiple reference variable. One object you can refer with multiple reference variable, but the condition is the type or the data type of that references should be of same type. The data type of that reference variable should be of same type. Okay, we can copy the reference from one variable to another variable of same type. If both the reference variable are different, then conversion of one reference variable to another reference variable is needed. Yes, type conversion we have seen. Can anyone tell me where we have seen type conversion? Yes, where we have seen type conversion? Anyone? Yes, can anyone tell me where we have seen like this? Yes, it is in typecasting. In typecasting, what we have seen, if you do widening, that's okay. But if you do narrowing from bigger container to smaller container, it was not possible. But we have to go. We have made it possible with the help of typecast operator. With the help of typecast operator, we have made it possible. Okay. Now here, okay, here this is widening, this is narrowing, this is for primitive. But for non-primitive, what do we have? Upcasting and downcasting. Okay. See, upcasting can be done easily, downcasting can be done with the help of typecast operator. Here, what is the problem is, you can take student object and you can store that reference is one more student object address. Okay, one more student object variable you can store easily. But if it is a different, you have to do type conversion. You have to do type conversion. So in order to do that, okay, in order to do that, we have to understand what is non-primitive typecasting. We have to understand what is non-primitive typecasting. So let us understand now what is non-primitive typecasting. So what is the reason we have to go for non-primitive typecasting? You can't store the reference of one type inside a reference of another type. If you want to do that, you have to do type conversion, and the type conversion is possible with the help of typecasting. Is possible with the help of typecasting. Okay. Next. So now let us understand our non-primitive typecasting. Okay, I told no future we will see this non-primitive and this is that future, and now you will be seeing a non-primitive typecasting. So in a non-primitive typecasting, okay, first of all, what is this? Non-primitive typecasting is a process of converting. It's a process of converting one reference type into another reference type. Another reference type. One reference type into another reference type is known as non-primitive, or you can also call it as a derived typecasting. Derived typecasting. You can call it as a non-primitive typecasting, or you can call it as a derived derived typecasting. Derived typecasting. Okay. One reference type, okay, will be converted into another reference type. One reference type will be converted into another reference type. So here now we'll be going for non-primitive typecasting or derived typecasting, which means we'll be converting one type of reference into another type of reference. One type of reference into another type of reference will be converting. So next what we will do is, okay, we have to understand what are the rules we need to achieve this. Okay, so the rules which we need to know, okay, the rules which we need to know to achieve non-primitive typecasting. To achieve non-primitive typecasting, what are the rules we have to understand? Now let us see. The first rule is there must be an easy relationship. There must be an easy relationship between parent class and child class. Okay, between between parent class and child class, you need to have a, I mean, between one class and another class, you need to have a parent child relationship. That is, there should be an easy relationship between two classes if you're doing type conversion. If you're doing typecasting, that is non-primitive typecasting, there must be an easy relationship between two classes. Okay. And one more way is there, like one more rule is there. If the class or interface has a common child, if the class or interface has common child, okay, if it is having a common child, then also you can go for non-primitive typecasting, which means see, easy relation should be there. Easy relation should be there. Yes, one parent one child, easy relationship is there. Okay, fine. But in class A, class B is there, single level inheritance goes on. Okay, non-primitive typecasting can happen because easy relationship is there. And if a class and interface has a common child, so assume this as a class and you have more childs here. Okay. um so we can do typecasting in all the inheritance. Okay, all type of inheritance we can do. So if a parent class in a multiple inheritance, you have a common child. For A also you have, for A also you have same child, and for B also you have same child. Here also you can do type conversion, but here it's not possible. You have to go for interface. Okay, if a class or a interface as a common child, then we can go for non-primitive typecasting. Okay, now let us see how it is possible. Okay, how the conversions are possible here. First let us see theoretically, and let us go for programs later. Okay, so if you're taking a single level inheritance, okay, if you're taking a single level inheritance, that is, if you take fruit and if you take apple here, and then if you're taking one more object here, one more inheritance, if you're taking vegetable and you are taking carrot. See, apple is a fruit, carrot is a vegetable. Apple is having easier relationship with fruit and carrot is having easier relationship with vegetable. That means apple is a fruit and carrot is a vegetable. Okay. Now, now how the type conversions can be here? Now listen carefully. Type conversion can be here. Fruit can be converted to apple. Fruit can be converted to apple, and apple can be converted to fruit. Fruit can be converted to apple and apple can be converted to fruit. Okay, in the same way, vegetable can be converted to carrot and carrot can be converted to vegetable. Vegetable can be converted to carrot and carrot can be converted to vegetable. But fruit and apple cannot be converted to vegetable and carrot. fruit and fruit and apple Fruit and apple cannot convert to vegetable and carrot. In the same way, vegetable and a carrot cannot convert to fruit and apple. Vegetable and carrot cannot convert to fruit and apple. That means this is independent, this is independent. You can do type conversion within this and you can do type conversion within this. You can't go out of this. Out of this you can't try to convert. Okay, this is about a single level. Now let us go for your hierarchical inheritance, wherein you have one parent and more than one child in the same level. One parent and more than one child in the same level. So you have a class fruit here, and you can have an apple class here along with a mango class. Mango class. Okay. Now, so fruit, listen carefully. Fruit can be converted to apple and fruit can be converted to mango as well. In the same way, apple can be converted to fruit and mango also can be converted to fruit. Apple can be converted to fruit as well as a mango can be converted to fruit. And here apple apple cannot be converted to mango and mango cannot be converted to apple. Here there is no conversation between child classes. No, there is no conversation going on or casting between child classes. No, it's not possible. There is only one thing possible, that is parent to child castings. Okay, so fruit to apple you can convert, apple to fruit you can convert, fruit to mango you can convert, mango to fruit you can convert. Okay, so this is possible. This is how you can do the inheritance, casting in your hierarchical inheritance. Okay, next, if you go for multiple inheritance, we surely have one common child here. Okay, two more than one parent class having a common child. This is called as multiple inheritance. Here we have a problem called as, yes, what problem we do have here? What problem, guys? Tell me what problem we have here. Yes, we have diamond problem. That is, class can extend only one parent class, but we have two here. There is a confusion happening. That is ambiguity. Yes, ambiguity is happening. So here, now conversion here is very easy. Okay, A to B you can convert. A to B you can convert. B to A also you can convert. A to B you can convert, and B to A you can convert because there is a common child. There is a common child. This is the second point in your rules of a achieving non-primitive typecasting. They have a common child here. Now A can be converted to B, B can be converted to A. Okay, and A can be converted to C and C can be converted to A. B can be converted to C and C can be converted to B. Okay. Here A can be converted to B, B can be converted to A, C can be converted to B as well as B can be converted to C. C can be converted to A and A can be converted to C. A can be converted to C. Okay. So this conversion is also possible. This conversion is also possible. Okay. So next, to understand this, okay, to understand this conversion, now let us do one small program for this. Okay. That is for understanding what is derived typecasting. Let us understand that. That is upcasting and downcasting. Let us understand that, and we'll proceed with some programs. So you have to understand some more about this non-primitive typecasting. Listen carefully. So non-primitive typecasting or derived typecasting, you can go for that is upcasting and downcasting. Usually in typecasting you have two types. Typecasting you have two types. That is um, primitive typecasting, primitive typecasting, and non-primitive non-primitive typecasting. Primitive typecasting and non-primitive typecasting. In primitive typecasting, you have two types, that is upcasting and downcasting. Upcasting and downcasting. In non-primitive typecasting also you have two types, that is oh sorry, primitive we have widening and narrowing. Yeah. Here we have widening. Yes, sorry. Widening, and here we have narrowing. Okay, non-primitive you have upcasting and downcasting. Yeah. So this we have learnt. Widening is done implicitly by the compiler. So implicitly it can be done, but narrowing should be done with the explicitly with the help of typecast operator. In non-primitive typecasting, for upcasting, it's implicitly done by the compiler, and downcasting you have to explicitly do with the help of typecast operator. Now how we can do? Now let us see. So first we shall take single level inheritance. So we will take single level inheritance first. Okay. Yes. There is an inheritance going on between. Okay, we have assume we have a class fruit here, and we have class apple here. Okay. So what is upcasting? What is upcasting? What is downcasting? Listen carefully. Upcasting means the process of converting child class reference into parent class type. Okay. The process of converting child class reference type to the parent class type. The process of converting child class reference type into the parent class reference type is called as upcasting. This is called as upcasting. See, upcasting is implicitly done by the compiler, okay, and it is also called as auto upcasting because of this. Since we call it as auto widening, here also we can call it as a auto upcasting because compiler will easily do it without any typecast operator. And upcasting can also be done using typecast operator, just like widening also can be done with help of typecast operator. We don't need that because here compiler is only doing by default, so you don't need anything else other than that. Okay. So narrowing, widening, it's in a primitive. Now in the non-primitive we have upcasting and downcasting. And see, upcasting, that is converting child class reference into a parent class reference. Converting child class reference type into a parent class reference type is called as upcasting. Now how can we do it? Okay. How can we do it? Very simple. Create one object for class apple, that is child class, that is apple a is equal to new apple of no argument constructor. So apple we have. Now let us create a fruit f is equal to we will give the variable a. We'll provide variable a. So here apple A is equal to new apple of no argument constructor. So fruit F is equal to A. This is where we go for upcasting. This is where we go for upcasting. Upcasting. Okay. So in the upcasting, what we have done in upcasting here, we have converted child class, that is child class apple is a child class, so apple child class into, we have converted into the object fruit. Okay, we have converted into object fruit here. Okay, and and here upcasting is possible by default because compiler will do it by default, so we call this auto upcasting. Upcasting means converting a reference of child to parent type. But we have one problem here. We have one problem. After going to parent class, you cannot access child class members. After going to parent class, you cannot access child class members. It's like, guys, after going to first floor, you can't access ground floor members. After going to first floor, you can't access ground floor objects. Yes, ground floor elements you will not be able to access. Assume you are in a first floor. Now from ground floor you have went to first floor. You are in first floor, so you can access only the elements of first floor. In case you want to access ground floor members, it is not possible. Once you have upcasted, the reference of child will be converted to parent. The variable A, now it is a child type, no, child type apple. That will be converted to fruit type. Okay, that will be converted to fruit type. That will be converted to fruit type. Okay, and since here, okay, so child class apple now we have converted into fruit A. Now after upcasting, that is fruit, upcasting to parent fruit type, you can actually access, yeah, we will do it. So we can actually access the members of only parent class. You can't access members of child. That is upcasting. That is a drawback here. So because of that, we'll be going for downcasting. Downcasting means converting parent type reference to child type. We are converting parent type reference to child type. Now how can you do it? Very simple. Take variable A. Apple already declared A is equal to, you can go for typecast operator apple, and you can place this variable F here. What we are doing, variable F we are taking, fruit type variable F we are taking, and we are converting it to apple first. We are converting it to apple first, and then we are going for storing the type of fruit inside apple. Okay, so let us understand this practically using our code, using eclipse with our code. Now let us understand. Okay, so we shall go for, okay, do we have any relationship? Yes. Okay, no problem, we'll go with this only. Now currently we shall go with the class fruit now. Okay, we'll change it to apple. Once again, we'll change it to apple because we can do in the same class. So fruit we have taken. Let us change it to apple. Okay. Okay, let us delete this class fruit. Okay, so let us create one class. Okay, because okay, we'll go for apple. Apple already exists. Okay, just a minute. Okay, so we already have a class fruit and apple. So what we shall do is, okay, let us go for a default package. Okay, let us go for class fruit. A vegetable also we can take. Okay, we can take vegetable also. Okay, we will take it. Banana. No, no, no. Wait a second. So we can take vegetable also. Any number of examples you can take. So we can go for carrot. Carrot is a child. So we can take a class parent, that is vegetable, and vegetable has a name. So string vegetable name and string vegetable origin we can go for okay, string v name and string vegetable color. Okay, so we'll be going for vegetable constructor vegetable. Okay, and we'll go for string v name comma string v color. So after this we'll go for initialization, that is this dot vname is equal to vname, and this dot v color is equal to v color. Okay, so we have done this. Now what we will do is we shall go for carrot. See, carrot is a normal class, right? Carrot is a normal class. Now what we have to do for making this carrot as a child for vegetable? Yes, guys, tell me what we have to do to make the carrot class as a child for vegetable. What we have to use there? Anyone? Yes, we have to use extends keyword. Not extend, it is extends. Yes, it is extends keyword. So carrot extends vegetable. Carrot extends vegetable. Okay, since we have carrot parent class carrot here, so it's telling to call it. Okay, no problem. Now, so we shall go for, okay, we're calling parent members and we're initializing. Okay. Okay, okay, no problem. Now, what we can do is we shall create an instance for the class. Okay, we shall create an instance for the class carrot. Okay, so how we can do? Now let us take a main method here. So in a main method, now let us go for creating an instance for, let's create an instance for child class, that is carrot. Carrot c is equal to new carrot of, okay, vegetable name is carrot, and vegetable color, it's usually we call it as a red color, but it's an orange color. Okay, so what do we have here? We have a carrot instance. Now with the help of C you can call attributes and you can do it, we can usually access it. Now if you're upcasting, okay, so let me write one carrot details method here. So we'll create one method here, public void carrot details method. So inside that we can go for printing vegetable name and vegetable color. Okay, see, if you go for carrot instance, we're just creating an instance for carrot and this members has been inherited, and now we shall call c dot carrot details, c dot carrot details method. So the output is carrot and orange. What error we have here? Already defined. We'll go for vegetables. Okay, why? What's happening here? Already defined. What vegetables we have here? Do we have vegetables here? Okay, you can go for veggies. Veggies also means vegetables only. Okay. Okay. So we are what we have done here. Yeah. We have done programs regarding this. Yes. So what we have done here, veggies. We have gone for vegetable name and vegetable color. We have an attribute here. And now we will be going for a veggie details method. We can go for veggie details method also. Yes, here we will go for one method, public void veggie details method. And here we'll be going for printing the vegetable name, and we'll be going for printing vegetable color. Okay. So yes, see if you guys are seeing here, listen carefully. Now what error we have? Errors is done. Okay. So if we execute now, we have created an instance for home for the carrot. So for the carrot, c dot carrot details, we have passed carrot and orange. So in the output, you have to get carrot and orange. Let us see the output. Are we getting carrot and orange? Yes, you are getting carrot and orange. Why? Because we have created an instance for the carrot class. We have created an instance for the class carrot. We have created an instance for the class carrot. Okay. And we are calling carrot details method, that is same class method. We are calling same class method. And here, since we are calling same class method here, surely it will execute. Okay, surely it will execute. If you want to access parent class method, that is c dot veggie details, also can access, that is c dot veggie details method. Can you see here, veggie details method also can access. Let us execute. So what are you getting again? Carrot and orange. Why are you getting carrot and orange? Because through the child class carrot, we have initialized the parent class constructor using supercall statement. Using supercall statement, we have initialized the parent class constructor. So it has been initialized. So when you're calling vegetables method, here you'll be getting vname and vcolor. So this is using child class, you can easily access. But once if you go for upcasting, that is veggies 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 v is equal to, now if you go for giving the reference variable of child c reference variable, you will be storing inside the vegetable. There is a relationship. The child reference we are storing inside parent. So child reference c, okay, c a reference variable, address we are storing in variable v. Now what happened? The child has been upcasted to parent type. Okay, so we have class veggie here. We have class veggie and class carrot. So when we are upcasting, carrot has been converted to, parent type veggie. And now only you can access veggie members. Now you can access only veggie members. You can't access carrot members. So that is a default here. You can't access carrot members because you have upcasted. Okay, you have upcasted. So that is the reason here. Okay, so what's happening here? If you are converting child class reference into a parent class type, you are converting child class into parent class type. Okay, now here we'll be going for, so v dot now. So how can you know that you are able to access only parent class but not child class? See here, with the help of the reference variable v, if you calling veggie details method, you are getting. Okay, but if you call v dot carrot details method, you are not getting. Why? We are not getting, because once the reference is upcasted to parent type, that is veggies parent type, once the reference is upcasted, you will be you will be accessing only the parent class members. So what are parent class members you have? These two attributes as well as this method. Okay. Now here we have veggie details method as well as a carrot details method. So veggie is a parent class, carrot is a child class. Okay, carrot is a child class. We have created an object for the child class and easily we can access both parent class and child class members. But once the reference of carrot is upcasted to veggie type, the carrot reference is once upcasted to veggies type, then we shall go for calling the members only of the veggies type. Okay, we can't call the um, elements of child type, that is members of carrot class you can't access. You can access only veggie. Okay, veggie details method, that's own class members you can access. This is the default, this is a drawback of your upcasting. This is the drawback of your upcasting. Okay, we will see how we can sort it out, we will see. Okay, so this is how we can do upcasting. And why we'll do upcasting is because, okay, let us know why we'll do upcasting. Listen carefully. One second guys, I'm getting a call. Excuse me guys, just a minute. Yeah, so here, yeah, so here what happens is, see, when there is one parent and there is one child class. Okay, if you go for veggie here and if you go for carrot here, you can easily create an object for carrot. Carrot c is equal to new carrot of no argument constructor. And now if you want to upcast, okay, if you want to upcast, that is you have to go for upcasting. You have to convert child class reference to parent type. You have to convert child class reference to parent type. That is called as upcasting. How we can do it? That is very simple. Fruit f is equal to c. Done. Upcasting done. Compiler will do it without typecast operator because here compiler will do auto upcasting. That is here like widening it will do. It will also do auto upcasting. Here directly it will convert to parent type. So no problem here. So directly compiler will be going for upcasting. And now when you're upcasting, that is control your, now you have a control in the parent class veggie. Okay, now when you're, okay, so I've taken fruit here. Okay guys, veggie. Okay, so we have converted carrot to veggie. Now since we have veggie here, okay, here now we have converted child type reference to parent type veggie. You can access only the members of veggie here. You can't access child class members. You can't access child class members. And one main reason why we have to go for upcasting is for generalization. For achieving for achieving for achieving generalization. For achieving generalization, we have to go for upcasting, which means, see, suppose you have one car class, like suppose you have a cab. So if you're booking a cab, there will be three options for you. If you're booking a cab, there will be three options. That is mini, macro, and prime. Mini, macro, and prime. You will get three options. Okay. So here, if you choose mini, also you're booking cab. If you choose macro, also you're booking cab. If you choose prime, also you're booking cab. Are you guys getting here? If you are choosing mini, also you're booking cab. If you're choosing macro, also you're booking cab. If you're choosing prime, also you're booking cab. And any one you can book at a time. Any one you can book at a time. So that is why this cab is generally created and kept. Okay, any number of child classes can upcast to the cab type. Any number of child class can update to the cab type. Okay, so here this upcasting helps to create a generalized container. See, now cab C is a generalized container. Now cab C is a generalized container. Now how can we create an instance? Listen carefully. Now cab C, now it is a generalized container. generalized container. And here, with the help of the reference variable C, you can create an instance of different objects. That is, you can upcast. See, you have created an object for cat C. Now, cat C, you can upcast from mini, you can upcast from macro also, you can upcast from prime also. Okay. So, C is equal to new mini. That is, you are giving an instance. Okay. Instead of just giving reference variable, instead of just creating object, you are directly giving the reference here. Okay. C is equal to new mini. Next, C is equal to new macro. C is equal to new prime. New prime. So instead of creating object and passing the address, directly I am creating object here and address will store here. Address will store here. That means we are converting child mini to parent type, your child macro to parent type, child prime to parent type. So we are doing this conversion. We are doing this conversion. Okay. So this is why we have to go for upcasting, and we have one disadvantage in this. That is, after we upcast, okay, after we upcast, we can't go for downcasting. After we upcast, so after we upcast, okay, you can't access child class members. So one main reason why upcasting has a drawback is, after you go to first floor, you can't access ground floor members, right? In the same way, after you upcast from the parent class, I mean upcast to the parent class, from child to parent you are converting, that is upcasting is happening. And if you want to downcast, okay, you have to convert parent type to child type. If you want to access child class members, see, after upcasting you can't access child class members. In order to access child class members, you have to go for conversion here. That is veggie to character type. Veggie to character type you have to convert. But how is this possible? It is possible. Now let us understand downcasting. Let's understand downcasting. Downcasting means conversion of reference variable from parent type to child type. Conversion of address or parent reference variable from parent type to child type. And in this conversion, okay, don't forget what is downcasting. Downcasting means converting a parent class reference type to a child class reference is called as downcasting. And see, while downcasting, this downcasting is not done implicitly. Implicitly, downcasting is not done by the compiler. You have to use, you have to explicitly use typecast operator, and you have to do. You have to use typecast operator. You have to use typecast operator, and you have to convert, and that is you have to do downcasting. Now, purpose of downcasting is, after we upcast to parent type, we will not be able to access child class members. Will not be able to access child class members. So that is why, in order to access child class members, we will be doing downcasting. Okay. So why we have to go for downcasting? If we have parent P and child C. So if we can do upcasting, how we can do? Parent P variable is equal to new parent of no argument constructor. We have created an instance of parent, and you can also create an instance of child. C of C is equal to new C of no argument constructor. Now here you can go for upcasting. That is, upcasting. Since you have created an object here, you can go for P is equal to C. That means P address, C address is stored. So C address, that is child address, is converted to parent type. Child address is converted to parent type. Parent type. Okay. And so after this, now while downcasting, see, after upcasting you can't access child members, so you have to go for downcasting. You have to go for downcasting. In order to go for downcasting here, okay, if you want to do downcasting here, you need a typecast operator, because compiler will not do it by default. Compiler will not do this by default, so you need a typecast operator. Typecast operator. So how we can do it? Very simple. Take the reference variable C. C is equal to C of variable P. C is equal to C of variable P. So parent type P we are first converting into child type. Parent type P we are converting to child type. Then with the help of reference of child, see, control comes back to child means obviously you can access parent members as well as child members, because members of parent will be inherited to child. Because members of parent will be inherited to child members. Okay. So this is about your upcasting and downcasting. We will understand the subcasting and downcasting and what is a problem we will face while downcasting. Everything we will see in tomorrow's class. Okay, and again we'll have this revision, that is casting again tomorrow. Tomorrow again I'll explain you. Okay, so hope you have understood today. Everybody got the concept. Tomorrow I will again teach you this. Okay, don't worry, because few members have not come. So tomorrow again I will teach. Okay, guys, and the code will be shared to you. Code and the design will be shared to you in few minutes. Okay, and that's it for today. And I am sorry for joining late because I had some work. I couldn't join on time. So yeah. So that's it, guys. Any doubts anywhere you have other than this concept? In any concept you have doubt anywhere? In case if you have doubt, you can let me know. Anywhere, any doubts you have? Okay, guys, that's it for today, and I'll see you guys in tomorrow's class, exactly at 7 p.m. Okay, yes, guys, have a great evening. Take care. Bye bye. Good night.